Welcome to our first episode in this Professor Scangrella. We're looking at the introduction to electrical circuits. So our format is primarily going over a Word document in Excel where I will just be highlighting. So again, we're looking at the introduction to electrical circuits. And so we're starting with the foundations. So I hope that you can see me okay and that you can hear me okay and that we get some basic understanding from the lesson today. As we begin, I want to introduce the different types of energy, right? We know that we have thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, also mechanical energy as well, right? For our lesson today, we are focusing on electrical energy. We want to try to see, what are the basics of electrical energy? How can we how does this energy work? How is it generated? How is it used? And what is the fundamental operating principle of this source of energy? So we are focusing on electrical energy, right? Now, the basis for electrical energy is the movement of free electrons. Again, so I'll make a note of that. The basis of electrical energy is the movement of free electrons. Very important. Movement of electrons. Okay, now from your basic, again, this movement of electrons, we want to figure out, how do the electrons move? How? We also want to figure out why do they move, right? Why does the electron leave the atom and become a free electron? So how they move and why they move, right? So again, we're saying the basis of electrical energy is free electrons. These electrons that are moving have energy, and this energy is converted into other sources. So one point that we also need to establish before we go forward is the conservation of energy. And that law says that energy cannot be created or destroyed, but it can be converted from one form to another, right? This is the law of conservation of energy. Again, it says that energy cannot be created or destroyed, but it can be converted from one form to the next. Now, of course, if you think of the way we use electrical energy, we convert it into other forms. For example, we convert electrical energy into heat energy to heat our homes with our heaters, or we convert electrical energy into motion, like in a blender or washing machine. We convert electrical energy into light energy, of course, in our homes. This is how we consume that energy. We convert it into a form that we want. Now, electrical energy is very popular because it can be easily transmitted from one place to the next using conductors. And we'll touch a little on that as we continue. All right, so we need to understand the movement of electrons and to know why electrons move. We need to look at the Bohr's model of the atom, where we can see which electrons are going to move. So again, here I have on here two examples that I got from a website of the Bohr's model for two elements. So let's start with copper, right? Now, we know that with the model for the atom, we have the nucleus in the center, which has protons with a positive charge, and it has neutrons with no charge, right? Around this nucleus, we have electrons, right? And the electrons are positioned in different shells around the nucleus. Now again, these electrons have a negative charge, and so they're attracted to the positive here. So the laws for charge we have, of course, just like a magnet, we know that like charges, this is the law that we need to keep in mind, that like charges are going to repel, like charges repel, and unlike charges are going to attract. So if I put a plus and a minus here, we know that we have an attraction here, right? Unlike charges are going to attract. So in the atom, we have an attraction between the electrons and the protons, right? So this, in a sense, is keeping the electrons bound to the, if you look here, we have an attraction here between the positive and the negative, right? You can see that some electrons are going to be at a greater distance to the nucleus than others, right? In fact, we are actually concerned about the electrons on the last shell which is called the valence shell. Now these electrons, they are further away, they are the furthest away from the nucleus, and so even though there is an attraction between the negative here and the positive in the center, the attraction is going to be weaker because of the distance. So the same way if you have two magnets and you put them together, the force is stronger with distance. Similarly, with these forces, the force is going to be weaker when you have more distance. This electron can then gain energy and become a free electron. All right. Before we look at these two examples here, I would just like to share with you just a couple of reasons why or how an electron can gain energy. Right, we're saying that the electron in the last shell is called a valence shell. How can an electron become a free electron? The first reason. So how do electrons gain energy? The first reason I have is thermal. Right? Electrons can gain thermal energy from the surroundings. Right? So for example, if you heat up a piece of material, that thermal energy now is absorbed by the electrons, and we can have an electron gaining enough energy so it can actually leave this atom and become a free electron in the material. We call it a free electron, right? So this is one way that this can happen is by thermal energy, right? Now, for example, in a conductor at room temperature, there is enough thermal energy so we can have a number of free electrons in that material. Another way electrons can gain energy is with voltage. So if a voltage is connected across the material, that voltage creates an electric field, and that potential, essentially it adds energy to the electrons. So if you look at the definition for voltage, voltage is the work done for every coulomb of charge that flows. Essentially, when you have a voltage across a material, you actually have energy that is being supplied by that voltage source to these electrons, and you have a certain amount of energy per every coulomb of charge that flows. In other words, and again, a coulomb is the unit for charge. The second, so a voltage source causes free electrons, right? And then the third thing that causes us to have free electrons is if we have light, right? Radiant energy. So light actually can impart energy to electrons, so we can have free electrons as well. And this is the same thing that happens in solar panels, right? The light is used to the photon, right, gives energy to the electron, and the electrons become free electrons, and these electrons move in the material, right? So again, looking at the structure of materials, we can classify materials in three different groups. We know of conductors, we have insulators, and we have semiconductors. And of course, I have a picture below, I'll show you. So on here we have two examples. For example, this one is copper, and you can see that the atomic number is 29, right? And we also have the mass number as well, right? If you look at copper here, we have 29 protons. We also have 29 electrons. So normally you have the same number of electrons and protons. And notice how they're organized, right? You have 2 electrons on the first shell, 8 on the second one, 18 on the third one, and of course the rest on the last one. So again, notice here, copper is a conductor. It has 1 electron on the last shell, which is the valence shell. And this is the shell that normally interacts with reactions with this material. On this side here, we have silver, and silver is a very good conductor as well. And if you notice the way the electrons are structured, we have 1 electron in the valence shell for copper as well. Sorry, for silver. In here, we have some examples of some conductors. Of course, you see gold, silver, copper, iron, aluminum are very good conductors. On the semiconductor side, we have silicon. So again, these metals here, they have 1, 2, 3 valence electrons. These ones, they have about 4, 5 valence electrons. So again, with the semiconductors, they are not very good conductors, but we can modify them to create electronic devices where we can control the amount of current flow. And of course, insulators, their valence shell is almost full. And as a result, it takes a large amount of energy for an electron to become a free electron. And so we have very few free electrons, or no free electrons. No free electrons. All right, with this ones, we have, it takes a very small amount of energy for us to have free electrons here, right? It's a very small amount of energy is required for the electrons to become free electrons for the conductors. Whereas with the semiconductors, it would take more energy for electrons to become free electrons here. So of course, in the conductors, we have many free electrons. Just as an example, in a piece of copper at room temperature, we have a number of free electrons that are present. That if you measure current flowing in that copper, you can actually get a small voltage across it. If you measure voltage across it, because of the free electrons that are present, because of that thermal energy, right? So again, we have conductors based on types of material. We have conductors. We have insulators, right? Very poor conductors. And we said one characteristic of this is that the valence shell is full, right? It takes a large amount of energy for there to be free electrons. And semiconductors, we can modify to make them into better conductors, right? So let's look at the circuit here. A circuit is really a closed path for electrons to flow, right? So I'll write that down, a closed path. What is a circuit? A closed path for electrons to flow. Okay, for electrons. All right, so what happens when you close the circuit, right? When you close the switch right here, because we have a battery here, this battery is a source of chemical energy. So when there's a closed path, then a reaction happens in the battery that produces free electrons. These electrons then are repelled from the negative terminal, right? And because when the path is closed, it's going to also establish a voltage here. So we're going to have a voltage present here. And this voltage will cause electrons to move towards the positive terminal. Again, this is the positive and negative terminal of the battery. We have two actions happening here. The voltage causes electrons to flow in a particular direction. I'll point the direction here. The voltage essentially the voltage provides energy for these electrons to flow. And again, if you express it in terms of the reaction, the chemical reaction produces free electrons with a particular energy level, right? These electrons, what they're going to do, they are free electrons and they travel through the material. So they're going to travel, and as the free electron travels, what happens is that it collides with other electrons and it loses that energy. And so what it's going to do now is going to recombine with another atom, and that can be an atom that is neutral in that it in other words. So again, if we mention here, we said that we can have free electrons, right? When that electron leaves, then we have a net positive charge in this atom right here. And so this atom now is this atom is attractive to a free electron, that a free electron can also recombine here, right? So we have this separation happening, the generation of free electrons, and we also have the recombining happening. So when the circuit is closed, these electrons travel, they lose energy, and they're going to recombine. So we have a number of free electrons being generated all over the material, and we also have electrons being recombined as well. So what I'm trying to say is that one electron doesn't travel all the way around the circuit, but we have this short distances being traveled, and we have the recombinations. And so this happens so that as soon as you turn your switch on, the light is going to come on immediately, because we have electrons moving all simultaneously in the material. Again, the electrons are moving a short distance, they are losing energy, and they are recombining. All right, they are gaining energy. So the energy source is the battery. The battery is supplying the electrons at a particular energy. Again, and our light bulb here will convert this electrical energy into light, right? So this is converting the electrical energy from the battery into light, right? So just before we end this video, right, we want to define current, right? What is electrical current? So this is the basic unit for electricity. If you look at this SI units, the SI unit for electricity is the ampere, which is the unit for current. Now, of course, we represent current using I, And again, the unit is the ampere or amps. Current is actually the rate at which charge moves in a circuit. Now, of course, we know that each electron would have a certain amount of charge. And so I have that right here. Let me just share it with you. All right, each electron would have a certain amount of charge, and that charge is, so the charge in one electron is going to be minus 1.602 times 10 to the minus 19 coulombs of charge, right? So you can see that it would take a large number of electrons to make up 1 coulomb, right? So current is actually the rate at which charge is flowing in a circuit. So current is the rate of charge flow in a circuit. In a circuit or at a point in the circuit, right? So again, think of it. If we had 2 coulombs of charge flow in 2 seconds, then the current is going to be equal to charge over time, which gives us 2 coulombs over 2 seconds, which would lead to 1 ampere, right? So again, current is the rate flow of charge. We have to keep this in mind. Current is a flow rate. That is why when we measure current, we are not going to measure current across any device, but we are going to measure the current that is actually flowing in the circuit. So normally the ammeter that we use to measure current acts as a jumper. And of course, we're going to explain it a little further as we continue. All right, so I hope this was just an introduction to electrical circuit. Again, just to reiterate, electrical energy is based on the movement of free electrons. Right, now there are different ways to get these electrons to move. We said here we have the 3 ways we said we can get free electrons. We said we can have a thermal source, right? Electrons can gain energy from thermal energy. Then if we have a voltage source or voltage potential, that can cause the electrons to move as well. And of course, we said light can also cause electrons to move as well. Right, and of course these 3 ways goes into how we generate electrical energy that we use as well. Okay, so we've come to the end. Okay, check out the next video where we talk about current, voltage, and resistance. Current, voltage, and resistance. This is Prof. Scangrella signing out.